Processing is a text-based language where the programmer defines a sequence of instructions to create or manipulate data visualizations or images. For example, if we wanted to create two circles and a rectangle as part of our data visualization, then we would use a sequence of processing instructions to create each of the shapes, which, when the processing code is executed, generates an image with the two circles and the rectangle. One of the most important concepts in any programming language is that of functions. A function is an existing set of instructions that serve as a specific purpose, much like mathematical functions that you might already be familiar with, such as these. A function is a collection of instructions that performs a specific task, such as calculating the cosine of a value. When you call or execute a function, you have to provide it with the information it needs in order to do its specific task, such as the cosine function. It needs to be given the angle for which the cosine value will be calculated. This is the same for any function used in programming languages. For example, a function that is used to create a rectangle, which in processing is the rect function, performs the task of drawing a rectangle, but it needs to know how large the rectangle should be and where the rectangle should be drawn. How we do this will be the focus of this first lesson. Processing has a wide range of existing functions that can be used to do powerful things to create and manipulate basic shapes. We will use a lot of these in this course. One of the most important functions to start with is the function size. Size is used to tell processing how large our canvas should be. Here we have used the size function to create canvases of different sizes, showing how we can create differently sized images. An important concept in processing is the use of coordinates. Images are created by specifying shapes and lines to be drawn, using coordinates to specify where in the canvas the shapes should be drawn, and also specifying their width and their height. This information is provided to our functions when we use them. In other contexts, we measure distance using metrics, such as centimetres or kilometres. In processing, we measure distance in terms of the number of pixels. As an example, this canvas is 200 pixels wide and 100 pixels high. And this canvas is 100 pixels wide and 400 pixels high. Each point on the screen is measured by a pixel. If you zoom in on an image, you will be able to see that it's made up of lots of little squares. These are our pixels. Our coordinate system using pixels is very important in processing, as it helps us form a grid to lay out our images. Once we have our canvas, we can use other processing functions to draw shapes as a starting point for creating our images. As we discussed when we use a function in our programming language, we have to provide it with the information that it needs to perform its job. We can draw our point on our canvas by specifying the x and y coordinates of the point using the point function. The x coordinate tells us how many pixels across the point should be, and the y coordinate tells us how many pixels down. Both of these values need to be provided to the point function when we call it. These are known in programming languages as the parameters to the function. We can also draw a line by specifying the correct function, in this case the line function, and providing the coordinates of the start and end point of the line. The line that we have just drawn starts at position 20 pixels across and 30 pixels down and is 80 pixels long. We can draw a series of lines in our images, placing them at different points by specifying different coordinate values when we call the line function. Our second line starts 30 pixels across and 50 pixels down, with its endpoint being 100 pixels across and 70 pixels down. We can draw lines on any shape wherever we want in our canvas just by specifying the coordinates that we want. In our earlier example, we used two functions to create two different kinds of shapes, the ellipse function, which is used to create ellipses or circles, and the rect function, which is used to create rectangles. The ellipse and rect functions need more information than the point function needed. In this case, it is information or data that is necessary to know where to place the shape and how large it should be. We can draw a rectangle by specifying the x and y coordinates for the top left-hand corner, where the x coordinate is how many pixels across and the y coordinate is how many pixels down. We finish off by also specifying the width and then the height. We can draw an ellipse in a similar way. In the next video, we will be explaining what data science is and explore how we can use code to create useful images and how we can program in processing to create graphics and represent data.